Namaskar, welcome to Exercise Explained. In this video, I would be doing question number 9 and question number 10 of exercise 5A Upthrust in Fluids, Archimedes Principle and Floatation, ICSE 9th Physics. The previous questions have been done in the previous videos, the link for which will be there in the description below. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 9th question. A block of wood is floating on water with its dimensions. So the dimensions are given as 50 centimeter into 50 centimeter into 50 centimeter. Inside water. Calculate the buoyant force acting on the block. So we need to find the buoyant force. We are supposed to take G as 9.8 Newton per kg. Now, Newton per kg looks new to us. So I would actually explain you what is the meaning of Newton per kg here, because this is the first problem where we are seeing Newton per kg. So I would write G is equal to 9.8 Newton per kg. So Newton per kg can be written as N divided by kg. Now Newton is the SI unit for force. The formula for force is mass into acceleration. So Newton can also be written as kg ms minus 2 divided by kg is there in the denominator. Kg and kg cancels. We are left with meter per second square. So whenever we get Newton per kg, we don't have to worry about anything. It is the same as meter per second square. So first I would be finding out the volume here. So once I find the volume, V is equal to length into breadth into height, or since it is a cube but it is not mentioned as a cube, I would write it as L into B into H. Usually when we have the dimensions given in any question of physics, it is of the form L, B and H. That means the first quantity is length, the second quantity is breadth, and the third quantity is height. So that happens to be 50 into 50 into 50. So 5 cube is 125, 125 and then 000 centimeter cube, which can be written as 125 into 10 to the power of plus 3 centimeter cube. Now centimeter cube is not the SI unit. We will be converting it to SI unit. So when we convert centimeter cube to SI unit, that is meter cube, we multiply it by 10 to the power of minus 6. I have explained this step by step how conversion from centimeter cube to meter cube happens in the first video of this particular exercise. If you have not seen this by now, do check that out. So here we get this as 125 into 10 to the power of 3 minus 6 is minus 3, and here we get meter cube. So we get this as 125 into 10 to the power of minus 3 meter cube. Now here it was written as water. So density of water, rho of water, we are supposed to take it as 1000 kg per meter cube. So now we would be finding upthrust. So upthrust will be using the formula V into rho into G. So V happens to be 125 into 10 to the power of minus 3 into density of water is 1000 kg per meter cube into acceleration due to gravity is 9.8. In all the sums of this exercise, we have taken acceleration due to gravity as 10, but in this particular sum, we are supposed to take it as 9.8. 10 to the power of minus 3 and 1000 cancels, because 1000 is nothing but 10 to the power of plus 3. So 125 into 9.8 gives us 1225 newtons. So the upthrust, we got it as 1225 newtons. So upthrust is nothing but our buoyant force. So I can write it as buoyant force. So hope this question is clear. Getting to the last question of this exercise, that is question number 10. A body of mass, so mass is given as 3.5 kgs. Mass is given as 3.5 kg. Displaces 1000 centimeter cube of water. When fully immersed in it, calculate the volume of the body. Now see, if anything, let's say there is a stone which goes inside water. If X amount of water is displaced, so that means volume of that, the volume of the body which is immersed will be equal to the volume of the water displaced. So here I would be writing volume is equal to 1000 centimeter cube, which is 10 to the power of 3. 1000 can be written as 10 to the power of 3, and once we convert it to kg per meter cube, we multiply by 10 to the power of minus 6. So plus 3 minus 6 gives us 10 to the power of minus 3 meter cube. After that, we would be using, so volume of the body, we already know it as 10 to the power of minus 3 meter cube, or we can call it as 1000 centimeter cube. It's pretty simple, no calculations at all. Second part, upthrust. So for upthrust, we know the formula V into rho into G. Now since it is given as water, density of water, we are supposed to remember it, that is 1000 kg per meter cube, which can be written as 10 to the power of 3 kg per meter cube, because 1000 is nothing but 10 to the power of 3. So volume here is 10 to the power of minus 3 into density is 10 to the power of plus 3 into acceleration due to gravity, we will consider it as 10. So once we do this, minus 3 plus 3 cancels, so we are left with 10 newtons. So that would be our upthrust, but it is given in kgf in the textbook. So when we are converting newton to kgf, we divide by 10. So 10 divided by 10 kgf, that gives us 1 kgf. So 1 kgf is going to be the upthrust. Now since we have got the upthrust here, we can write upthrust is equal to weight of the body, since we have got the value of upthrust here, we need to find apparent weight of the body. So once we are finding the apparent weight will be equal to weight of the body in air minus upthrust. So that is the formula for apparent weight. Now for finding the apparent weight, upthrust we already know it. So weight in air is nothing but mass into acceleration due to gravity. So mass is given as, I forgot to write that here, so mass is given as 3.5 kg. So we can write weight in air as m into g minus upthrust is 10 newtons. So m into g will give us 3.5 into g is 10 minus upthrust is 10. So 3.5 into 10 gives us 35 minus 10. So 35 minus 10 is nothing but 25 newtons. So 25 newtons is our apparent weight. If we convert it to kgf, we are going to divide it by 10. So 25 by 10 gives us 2.5 kgf. So 2.5 kgf will be the apparent weight. So we have got apparent weight of the body in water, we have got upthrust, we have got the volume. So we have got all the three things. So that completes this video. I hope you guys have liked the video. Do share it with your friends and consider subscribing to the channel. So see you in the next video, in which I would be solving exercise 5B. The playlist link will be there in the description. Do check that out. So see you in the next video. Dhanyavad.